Hello everybody, welcome back to our channel. In this episode we're going to be solving a Physics 7B electric circuits practice problem. As usual, if you're finding this content helpful, please make sure to leave a like and subscribe, it really helps our channel. So this is the circuit that we're going to be working with. It's a funny looking circuit that actually has two batteries instead of the usual just one battery. And the instructions are sort of like straightforward. We basically need to find the current through each of the resistors, and then at the end we need to figure out the power that's added to the circuit by each of the two batteries. So as you can see, I have the funny looking circuit over here, and so let me just say that whenever you have this sort of problem in which you're just thrown a circuit and you have to find something, there are a lot of ways, and by a lot I mean a lot of ways in which you can actually solve this problem. There is no a step-by-step that's gonna be, ideal, or that's gonna be the only right way to solve this. So I'm just gonna do this, kind of like how I would just do it by myself if I had this problem just by myself. But please know that, if you're trying to solve this problem and you have like your own way of solving it and you get the exact same results, then that is totally fine. So let me just go ahead and, I can't possibly go through every single way in which this problem can be solved, because I would end up making probably 15 videos on this, and that is not the idea. But I'm just gonna do it my way, and I'm just gonna try to be very, explicit about why I'm doing the things that I'm choosing to do. Now, the first thing is just looking at the instructions. I have to figure out the current through each of the resistors, which means that basically what they're asking me to do is find every current on the every single current that's on this circuit I have to find. So let's just try to figure out, first of all, how many currents do we have in our circuit. The first challenge that we encounter is that we have two batteries instead of just one. Usually there's just one battery, and then whatever current is crossing that battery, that is gonna be the total current. But now we have two batteries. So whenever I have a problem that has more than one battery, the first thing is that I always write the total current as the current that's crossing the biggest battery. So in this case, I always go from minus to plus on the biggest battery like this. Now both of my batteries are 2 volts and 5 volts, so I'm choosing to use this one as my reference point. Now, on this particular quiz, we are actually a little bit lucky, because even though we have two batteries, both of them are connected in series with each other instead of opposing each other. So this current hits plus minus, then plus minus, which means that these two are working together instead of against each other. So even if I had chosen this as a reference point to say that the current goes this way, then either way my answer would be correct. But I just always sort of like make it a point to use the greatest one as a reference, because if these batteries were opposing each other, then obviously you can only have a current flowing on one direction, not on two directions. And if these two were opposing each other, then this one would win, because this one has the highest value. So I kind of just learned, maybe 10 years ago when I was first studying this, that the only way to always get this right is if you use this one as reference and then see how this one compares to this one in terms of polarity. Are they working against each other, or are they working together? In this case, they are actually working together, so there's really no issue. So anyways, I have a total current, and then this total current is gonna hit this junction over here, and it's going to split into two different currents. So it's gonna split, and a little bit of the current is gonna go like this, and I'm just gonna call this I3 because it crosses R3, and a little bit of the current is gonna actually go this way. and I'm just gonna call this I4 because it crosses R4. Now these two currents are gonna go up like this, and then once both of the currents hit this junction over here, they are going to recombine. So that gives us a total of currents. We have a total current, and if we use our continuity equation over here, what goes in must go out. So this has to be equal to what I'm calling I3 plus this other current that I'm calling I4. So we have three currents, and obviously if we can figure out the values of these currents, then the problem is solved, because the current through this resistor is I3, the current through this resistor is I4, and then the current through these two resistors is just the total current. So if I figure out these three, then my problem is solved and I'm done. Now obviously this is not as straightforward, because now, like, what are we gonna do? And this is the part where, you know, some of you might decide to start working on reducing your circuit in order to have less resistors, and that would be fine. What I'm gonna do is, because I have to find everything anyways, what I'm gonna do is I'm gonna try to use loops in order to solve this problem. Now, how many loops can I make? Well, I can actually make two loops. So I can make an inner loop that basically does this. So let me just write the equation for this loop. So I start over here, and the first thing that I encounter is this resistor. So this is negative I total times R1, which is equal to 12. The next thing that I encounter is this battery. So this is just +2. The next thing that I encounter is this resistor over here. So this is negative I total times 10. And then I hit this junction. The next thing that I encounter over here is this resistor over here. But this resistor is not being hit by I total, so I need to be very mindful. This is negative I3 times 24. And then the last thing that I encounter is this battery, so this is just +5. And because I did a full loop and I'm back at the beginning, all of this has to be equal to 0. So now, simplifying a little bit, I have -22 I total, because I'm combining 12 and 10, -24 I3, and then this has to be equal to 5 plus 2, so this has to be equal to -7. So I can just do plus, plus, and plus like this. So this is, you know, I'm just trying to reduce terms and just trying to make it look a little bit cleaner. But this is my first equation that I have. So now another loop that I can do is start over here. And I'm just gonna draw it from the outside. And I'm just gonna follow this path over here. But instead of going up here, I'm just gonna go the outer loop, like this. So now, instead of following the red path, I'm deciding to take the outer way and just go all the way and hit this resistor instead. So for this loop, my equation will be, the first thing that I encounter is this resistor over here. So negative I total times 12. Then I hit this battery, which is just +2. Then I hit this resistor, just as with the red loop. So this is negative I total times 10. But now, instead of following the red path, I'm deciding to take this way over here. So now I'm hitting this resistor instead, and this is negative I4 times 8. And then I go all the way over here, and then I'm crossing this battery, so this is +5 and this is equal to 0. So if I rearrange my equation so that it looks kind of like this one, this is gonna be again 22I total plus 8I4, and this has to be equal to plus 7 again, like this. So now what do we do? Well, we have two equations, but three things that we don't know. I don't know what I total is, I don't know what I3 is, and also I don't know what I4 is. However, whenever we do loops and whenever we have currents, we also have our auxiliary equation. So we have three equations and three things that we don't know. So at this point, we're pretty much done with the physics, and we just need to do a little bit of algebra to sort of like solve for all of these currents, and then by the end of this we should be able to figure out what each of these currents are. So let's just go ahead and get started with that. Okay, so I decided that just for the sake of keeping everything clean and neat, that I would start over on a new page. So I basically just copied the three equations that I have over here in a new page, and like I said, at this point the physics is done. I just need to solve these equations, and then I'm gonna be done with my problem. So there are a lot of ways in which I can do this, but the first thing that comes to mind is just subtracting these two equations over here, because they have terms that are similar to each other. So if I subtract them, then this is gonna go away and the 7s are gonna go away. So if I do equation 2 minus equation 3, then the equation that's gonna come out of it is that 24I3 is equal to 8I4. And then this means that I4 is equal to 24 divided by 8. This is equal to 3 times I3, like this. So now I have this equation, and what I'm gonna do is I'm gonna substitute this equation over here. So I'm gonna take this value and I'm gonna substitute it over here. So I total is equal to I3 plus 3 times I3 per this equation. So I total is equal to 4 times I3. And now I'm gonna take this equation and I'm gonna substitute this I total with this value over here. So this is 22 times one I total is equal to 4 times I3. So this is times 4 times I3 plus 24 times I3. At this point I'm just copying this. This is equal to 7. So now I3, I need to add these things, right? So this is 24 plus 22 times 4, 112. Then this is equal to 7. So I3 is equal to 7 divided by 112. So this is equal to 0.0625 amps. So 1 current down, 2 to go. Now I already have an equation that's gonna give me I total over here. So what I'm gonna do is I'm gonna take this number and I'm just gonna multiply it by 4. So I total is equal to 4 times 0.0625. So I total is equal to, so 0.0625 times 4, 0.2496. And that is 2 currents down, 1 to go. And now what am I doing? Oh, well, I can just use this one, right? So I4 is equal to 3 times 0.0625, like this. So times 3, I4 is equal to 0.18, oh, that's a 1872 amps final answer. And now, just to check continuity, if I add these two, I should get this number because they should add up. So I'm just gonna do a very quick check. 0.0625 plus 0.1872. Yes, 0. To the 4th decimal, we're okay. So that means that I did everything right. So this is basically how I would do it. I would just solve the equations, and now I basically need to go back and give some final answers, right? So the current through R1 is just the total current. So the total current is 0.2496. The current crossing R2 is also the total current. So same final answer. The current crossing R3 is what I called RI3. So that would be 0.0625. And then the current crossing R4 is the current that I decided to call R4. So 1872 amps. And then final answer to part A. So now the only thing that we have to find is, in order to finish our problem, would be the power that's being introduced to the circuit via the 2 batteries. So now I basically need to remember my equation. So the power that a battery is supplying is equal to the amount of volts that it is supplying times the current that's crossing that battery. So for the 5-volt battery, this is equal to 5 volts times the current that's crossing this battery. The current that is crossing this battery is just the total current. So this is times 0.2496. So the 5 battery is supplying a power of 0.2496 times 5, 1.248 watts. Final answer. And the power that the 2-volt battery is supplying, again, same equation, it's E times I, so this is 2 volts. The current that's crossing this battery is also the total current, so this is 2 times 0.2496. So the power that this battery is supplying is 0.2496 times 2, 0.4992 watts. And there we go. So this is the end of this practice problem again, and I cannot stress this enough. There are a lot of ways in which you can actually solve this problem. I decided to go and use a way that was very algebraic because I decided, like, you know what? I am just not in the mood to start reducing my circuit and like drawing 3 different versions of my circuit and then just going back to this one. So I was just like, you know what? If I have to find every single current, then I might as well just do one step, one system of equations, and then just solve that system of equations. And that is basically gonna give me all of the answers that I need. which is what happened. I used my system of equations, and at the end I got all of the answers. Obviously, if you had worked in reducing the circuit, which I think that the proposed solutions on the PDF do this, so feel free to check it out, then you're gonna have a little bit of a more you're gonna have a little bit of more procedure, in my opinion, because you're gonna be doing more physics, you're gonna work some reductions, and honestly, and this is the reason why I decided to just do it this way, is because even if you reduce your circuit, you're still gonna end up doing loops in the end. So you might just do one loop. No, you still would need to use your loop rule twice. So you would still need to use loops. You would just end up with like less algebra. You would still need to do at least 2 loops, but because you're doing some groundwork to make this simpler, you wouldn't need to do a system of equations. So this is one of those problems in which you basically pick your poison. Like, what do you want? Do you want a lot of like small steps, or do you just want to do one step and then just do a bunch of like little equations that you would get to solve? I honestly don't have a preference. Sometimes I just feel like I don't want to reduce circuits. Sometimes I just feel like I don't want to solve equations. My recommendation is to always try to solve a circuit like in more than one way, because this is honestly the only way in which you're gonna be able to assess what are you better at. Like, are you better at figuring out series versus parallel and reducing your circuit? Or are you better at like, you know what, like I don't even care, what I'm gonna do is I'm just gonna do loops and algebra, because I've been doing algebra for like 10 years versus I've been doing circuits for like 1 week, so I'm just gonna go ahead and do what I know how to do. But it's personal preference, so definitely feel free to try this out in like different ways. I really like this problem because the instructions are just basically like, go crazy, do whatever you want, I'm not gonna guide you. And I do like problems that in which the student has freedom to decide, what tools that they learn they're gonna be using. So anyways, this is the end of this video, and I really hope that this was helpful, even though this is only one of the possible methodologies that you can use in order to solve this problem. If it was helpful, please make sure to leave a like and subscribe. It really helps our channel. And if you have any questions regarding this circuit, then feel free to leave them in the comments. We do read them and answer them. So I'll see you guys in the next video.